Elementary Algebra, Assessment 4 Review, questions 13 through 17. For question number 13, the instructions read, factor, if the polynomial is prime, so state. So question number 13, we have an x squared plus 3x minus 108. We have nothing in the a position, nothing in front of the x. So all we need to do is pull out what the c value is, which is a negative 108, and what the b value is, which is 3. And we're going to find a set of factors that create a negative 108, but when summed, create a positive 3. So I come down here, and again, I've listed more than I probably need, but I wanted to go all the way through the list just as an example. So I started with a 1. A 1 times 108. Well, I also know that one of the two has to have a negative sign on it because the answer out here needs to be negative. But also on the other side, I'm going to need the answer to be positive. So looking at it, I want to make sure that the smallest of the two factors gets the negative sign so that when it's summed, it creates a positive value on the other side. So a negative 1 times a 108 makes a negative 108. A negative 1 plus a 108 makes a positive 107. That one's not going to work, so I move on to a 2. A negative 2 times a 54 creates a negative 108. Negative 2 plus 54 creates a positive 52. Still too big. Keep going. A negative 3 times a positive 36 creates a negative 108. A negative 3 plus a positive 36 creates a positive 33. Not quite there. A negative 4 times a 27 equals a negative 108. A negative 4 plus a 27 equals a 23. Next would be a 5, but number is ending in 8, so I know it's not divisible by 5, so I move on to the 6. A negative 6 times an 18 is equal to a negative 108. A negative 6 plus 18 equals a positive 12. I don't have a 7 times anything that will get me to a 108, nor do I have an 8 times anything that will get me to a 108. But I do have a 9. So a negative 9 times a 12 equals a negative 108. A negative 9 plus a 12 equals a 3. There are my pair of factors. Now this one's a little bit easier because there isn't anything in the a position. So all I need to do is come down and write my parentheses and split that x to the second power apart, so x and x into each of these, and then just add in the factors that I found. So a minus 9 and a plus 12. Now I'm done factoring. Question number 14 reads, factor the trinomial containing two variables if the polynomial is prime, so state. So when I look at this one, when I look at the back end here, what I have is a v squared with it. So that v squared has to go with the problem as well. So when I pull them out and I look at the c value, my c is actually this time instead of just a negative 40, it's a negative 40 v squared. My b position then is going to be my negative 3, my constant, with the same variable that I see on the back end, which is the v. So a negative 3 v. So I'm going to pull that out. So that when I come down here, I'm going to include the v in with my factors, so that when I multiply, I get that negative 40v squared, but when I add, I get the negative 39v. So again, just like with the others, I've listed through all the possibilities. I started with the 1v times a 40v. I need it to be negative, but I also need on the other side for my answer, if you remember with my b value, to be negative as well. So this time I'm going to make sure the negative goes on the larger of the two. So we can see how I did this for 1 times 40 and 2 times 20 and 4 times 10 and a 5 times 8. This one ends up working. A 5 times a negative 8 equals that negative 40v squared, and then a 5v plus a negative 8v equaled a negative 3v. So I found my factors. So again, because there was nothing in the a position, all I have to do is write my parentheses, split my front variables apart, so it's a u in the first one, a u in the second one, and then plug in those factors I found. So u plus 5v and u minus 8v. Moving on to number 15, it says factor completely. Again, it says if prime, so indicate. So on this one, I have a value in the A position and in the C position. So I'm going to use the A times C method on this one. That means that this one's going to have an extra step of factoring by grouping once I find those factors. So a 6 times a negative 6 makes a negative 36. In my B position is a negative 5. So just as an example in the instructions, again, I listed everything, but a 4 times a negative 9 creates a negative 36, and a 4 plus a negative 9 makes a negative 5. So the factors I'm going to find are 4 and negative 9. But if you didn't know them, work the list, work it all the way down until you run into the correct pair of factors. So I'm going to replace that middle one with those two factors, so I have a 6z squared, and I'm going to put the minus on this side. So because a 6 and a 9 I know will go together well, so I could have put the 9 on the back as well and just switched their positions. It still would have worked. But minus 9z plus 4z minus 6. And then I went in and I grouped these two. I see that the first pair have a 3z in common, so I factored it out. Leaves me with a 3z times a 2z minus 3. I see that the back two terms have a 2 in common, so I factored the 2 to the outside. Once it's divided out, I'm left with 2z minus 3. Again, looking at the left to the right of the plus sign, I have the binomial 2z minus 3 in common, so I'll divide that out. It came out here, 2z minus 3. When that's divided out, it cancels down to a 1, and what I have left up there is the 3z plus 2. On problem number 16, we have a 15y squared plus a 19y plus 6. Again, this is going to have to be an A times C method because we have a 15 in the A position. So I take the A position 15 and I take the C position, which is a 6, and multiply them together to find I have a 90. And then in the B position I pull that value out and it's a positive 19. So I know I'm trying to find factors of 90 that sum to 19. So that's what I've done here again. I've started with the 1 times 90, then the 2 times, the 3 times, and so on, until I found the correct one. The correct one was 9 times 10 equals 90. 9 plus 10 equals 19. So I found my 90, I found my 19. So 9 and 10 are going to be my factors. So I come in and use those two to replace the middle term from the original. So I write down the 15y squared, and now I replace that middle term, that 19y, with a plus 9y plus 10y, and then just carry down the plus 6. Now I'm ready to group them. So I put my parentheses in there, and what I have in common in the first pair is a 3y, so I'll divide that out. That leaves me with 3y multiplied to a 5y plus 9. In the second pair, what they have in common is a 2, so I'll divide that out, and I'm left with a 5y plus 3. So again, left to right, the 5y plus 3 are what they have in common. So I divided them out, crossed them out, they were canceled down to 1s, and I'm left with 3y plus 2. Now for question number 17. It says factor the trinomial that is a perfect square. If it is not a perfect square, respond not a perfect square. Well, let's look at the rule for a perfect square. We have up here for number 17 a 16x squared plus 8x plus 1. The rule for a perfect square is factoring a perfect square trinomial is that the A position, the front position, is going to be squared, and the last position can be squared, and that the A times the B position times the 2 will equal what's in the middle. Well, let's look at that and see. Right? So I look here, I have a 16x squared. Well, that 16 can be squared, so we have a 4 squared x squared. So far, so good. We've got the A position squared. Look on the back side, I have a 1. I can square a 1 without changing the value. 1 times a 1 is still a 1, so that can be squared. So that's looking good. So let's check the middle. We're going to take what's in the A position, the base is only, so the 4x, times the base from the B position, which is the 1, and we're going to multiply that by 2. So 2 times 4x times 1, and that results in an 8x. So looking at this one, it's a perfect square trinomial, so I can use the shortcut. So I look up here, I've got two possibilities. If it's summing all the way across, I use the first one. If it's subtracting in the first position, then I use the second rule. This one's summing all the way across, so I'm going to use the top one. So I've already proved that it meets this part of the equation, this a squared plus 2 times ab plus b squared. So the answer has to be the a plus b squared. So I'm going to come down there and pull that. So my base here is 4x for my a, so 4x. And on the back side it's a 1, so I put that plus 1, put it in parentheses, and bring it to the second power. So I've completed the problem.